Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for the Technology, Media, and Telecom at S&P Global Market Intelligence. And today is our 100th episode, and I was thinking we'd look a little further ahead than we sometimes do, although it's a topic that I think has certainly been receiving an awful lot of attention recently, talking about the next generations of AI and its applications, the kind of things we can do with it. And to help me sort all of this out, we've got returning guests Nick Patience and Dan Thompson. Welcome back to the podcast, both of you.
Thanks a lot, and congratulations on the 100th episode.
Yeah, thanks, Eric. It feels like a portentous moment.
Well, it is, and I think we've got a portentous topic to talk about. When we start thinking about the idea of generative AI, I think we've all probably seen the headlines around ChatGPT and everything that OpenAI is doing. There are a whole bunch of different pieces, and actually for this show, I've put together a couple prompts that I fed through ChatGPT to talk about the challenges of doing a podcast on emerging technology and the benefits of emerging technology in general. And as a teaser, at the end of the show, I'll actually have my synthesized voice actually read some of this. So we'll head into that. But it's an interesting point that we seem to have gotten to when we've now gotten into an environment in which we've stepped beyond some of the machine learning, some of the more rudimentary pieces. But we've now got a way for technology to actually create new things. And I guess, Nick, I'll start with you. Is that really the fundamental definition of generative AI?
Creating new things? Yeah, I guess so. And building on what's gone before. I mean, that's the key thing, I guess, because obviously the generative AI models that underlie all this are trained on existing data. So essentially, they're kind of the prediction systems in a box. They read, summarize, and translate previous text, and then they can generate sentences similar to how humans talk and write as a result of that. So they're taking over from where humans left off, and then kind of almost predicting the sequences afterwards. I use the word predicting because when you get into things like proteins and stuff like that, not words, not even software code, but it's very much gets into that kind of mode. But yeah, they are. And I think this, having looked at this space for machine learning for 20 plus years and always been really fascinated by the fundamental problem that computers have with human communication and language in particular, it feels to me like we're at a real inflection point. And I don't really ever use that term very often. But I think this is something fundamentally different from what's gone before.
Well, and the other piece I think that's interesting about it is that it's a combination of not only the ability to do the generative bit, but also a natural language processing front end that turns out to be pretty effective at parsing real requests from real humans about what they're looking for, and then being able to actually use that as the front end for the generative process.
Yeah, that's right. I mean, they very much are that at the moment. And obviously, everything that they produce then gets fed back in as well. And so, and obviously, ideally, when we get these things to be more, commercial products rather than research, free research tools that are not, don't necessarily have all the kind of feedback loops. Once we get those loops working, these things will feed upon themselves. Now, you see a lot of kind of people concerned out there about, the internet may be full of enough nonsense already. Why do we need to keep generating more? I don't really think that's the concern here too much, because I think human beings will carry on doing that anyway.
More cat videos, come on! What could possibly go wrong?
Exactly. But these things, we can filter these things out. But the really exciting stuff, I think, these generative AI models in the short term, these large language models, these are going to become a layer in the platforms that underpin every application. And I think it has, for that, it has huge implications rather, because whereas it might be starting in areas like, writing assistants for marketing technology or just writing assistants just for the sake of it, as you get into more and more things that can be, semi-automated in terms of our communication, it's really exciting. And it also has legal and regulatory implications later on as to, is this a software writing? Is this a human writing? And things like that. But in the short term, I think this is a really important moment. And it's all really, we're going to talk about ChatGPT later, I guess, but it's all just exploded in the last couple of months, essentially. I mean, OpenAI has been doing what it's been doing for years, but until you put a front end on it that everybody could understand and use, and a very rudimentary front end, but it was largely hidden from view.
Well, that's an interesting aspect of the surge in use and understanding, and I guess just fundamental awareness. It was the first time just yesterday when I was using it. The first time I'd actually gotten a "we're too busy to do anything right now" message from ChatGPT. And so clearly, the world seems to have woken up to the fact that it exists. But there are a set of practical things that I think that we're doing with a lot of these more sophisticated models. And Dan, you're here to talk about some astrophotography aspects. For those of our listeners who don't know, Dan is actually an accomplished photographer. And I hadn't realized also does a lot of work in astrophotography.
Yeah, thanks. And I will say that my love for astrophotography is rooted in the fact that it's the intersection of science and art. And so for my brain and just sort of the way I function, it's really exciting hobby to participate in. And because of that intersection, we're getting to see now developments from the science side of things, particularly through the use of AI for the betterment of our end product, which is an image of an interstellar thing, right? So yeah, let's talk about that.
Yeah. All right. So we've got a bit of a setup here. You have sent Nick and I some images, and what we're going to be talking about is AI techniques applied to image enhancement, and basically tackling what is a complicated problem in making what are complex images. I mean, image enhancement for a lot of the things we've typically been able to do with Photoshop, changing colors, sharpening, blurring, all those tools that people have used for ages and ages. When you start to get to astrophotography, life gets a lot more complicated.
That's right. And there is a particular focus on accuracy. So when we look at astro images, there's a whole segment of the community that seeks accuracy. So they're looking for a very scientific image result, not necessarily supremely artistic. Now, there's some debate about that, of course, in the community. But anyway, so if you would just humor me for just a second, to kind of properly appreciate what this new software is doing, we at least need to have kind of a rudimentary understanding of the problem that it's solving. So if I may, just an ounce of background here.
By all means.
All right, great, wonderful. So when we look up at the night sky, we will see a host of tiny stars, right? And so each of those stars is itself a singular light source. To our eyes, it's super, super tiny, right? To capture that light and all the nebulosity and sort of the structure that exists around those stars through space as we see it here on Earth, we have to use a number of instruments, to do that. So one of those is called a tracking mount. It literally is what you bolt your telescope and your camera to. It's designed to follow the stars across the night sky because obviously we're spinning, so all these objects appear to move to us. And so this device compensates for that. Because these light sources are very dim, the camera exposures have to be very long, so to collect that light. And so that's the reason for needing that mount. Within these imaging systems, there are all sorts of opportunities for errors, as you might imagine. So there's things like imperfections in the telescopes that we use, tracking errors with that mount that I just described, and so on. There's also imperfections in the sky. So due to atmospheric conditions, things like turbulence, things like this, all of that can affect our viewing as we stand here on Earth looking up in the night sky. And so the net effect of all of this is those tiny light sources that I was just talking about a second ago, by the time they reach our camera sensor, it's a bit of a smudge rather than a focused dot, right? And so the difference between that perfect point of light and the smear that is essentially what our camera collects, we refer to this as a point spread function. So you can kind of think of it as a point of light and now it's spread out. What's the function of that spread? So there's a little bit of a background. So there are a couple of things that we can do to improve the point spread function, the greatest of which is actually to put our telescope in space. So now you kind of get the sense for why the James Webb telescope is so important, why the Hubble telescope has been so important. Once you get it out of our atmosphere, you've eliminated a lot of just the natural occurrences to the seeing problem. if you will. We can also improve our instrumentation. Again, see also the tons and tons of dollars that have been spent on James Webb and Hubble. That you and I, as mere mortals and individuals, we could never afford this, right? So that is how we kind of, as a scientific community, overcome those issues. So we can also use software to fix the point spread function through a process known as deconvolution. So essentially, deconvolution is a mathematical process, but the effect of it is it ultimately sharpens our image, not only the stars themselves, but the entire image. However, deconvolution as a process has always been super, super challenging, to the point that myself, I have admittedly kind of given up on it because it is just so challenging to get right.
Well, it seems like one of those things we think about the way in which we've applied filters in Photoshop. It's you can do a whole set of things because I'm assuming there are probably convolvers that are available through Photoshop or image processing software, and it's always a little too much of this or not enough of that, and depending upon the nature of the image, you may want to sharpen some areas more than others. It starts, any uniform process applied to an entire image is never going to get all of those pieces right.
You got it.
Right? It seems like that's usually the problem.
You got it. Exactly. So enter.
And so the question is, how do you then apply the right pieces to the right parts of the image? It seems like that's really what the challenge is, right?
You got it. Exactly right. And so enter Blur Exterminator. So this is the new software that I'm super, super excited about. The rest of the astrophotography community is also excited about this, somewhat cautiously in some circles. But what the software does is it leverages AI to analyze the images that you create, and then it mathematically compares those to what it has been built on, the model that has been given. So the model, the folks that created this software, they trained the model using images collected by Hubble and James Webb. Now, let me let that sink in for just a second. So you and I, as amateur astrophotographers, can leverage data that was collected by these super, super expensive NASA telescopes that are sitting out in space to mathematically correct our images that are in some cases gathered in our backyard, right? So this is like really, really crazy that this even exists, but it's super, super cool. So in terms of imaging, what this allows us to do is sharpen those images. It allows us to take those smears that were supposed to be stars and correct them. Again, this is all mathematical, correct them so that they are single points or at least better than they were. So what I have done, because of the medium here that we're operating in, which is a podcast, I wanted to kind of get some feedback from you guys. So you guys are not astrophotographers, maybe have not seen this type of thing before, but so I have just emailed actually 3 images that I want you to see. So in your inbox should be sitting, it's one image actually that has 3 panels in it. The leftmost, so what this is a picture of, it's called the Elephant Trunk Nebula. And if you look at it just right, you would say, oh yeah, that does kind of look like an elephant trunk. What this is for our audience, it's essentially dust that is sitting out in outer space and is being illuminated by nearby stars, and it creates like what looks like an elephant trunk, except it's all pink. So gentlemen, so what you have in front of you, the leftmost pane is an unaltered image that's just straight out of the camera, so to speak. The 2 images to the right of it have been altered by Blur Exterminator. There's a structure kind of below and right of center that you should notice, to my eyes anyway, a sort of a dramatic sharpening. So let me let you guys open that and kind of comment on what you're seeing.
All right. It does look kind of elephantine. I get your point. And interesting. So the first one seems, I mean, we are Stardust, right? Aren't we? Quote a good song. But yeah, there is some dramatic sharpening in that final picture that actually shows that sort of dust structure behind it. It looks like the points are a lot brighter. There just seems to be an additional level of clarity that's brought to it. I don't know. What are your thoughts, Nick?
Yeah, I'd agree with that. The other thing I just noticed looking at the 2 enhanced ones, and I'm trying to describe what I'm looking at. In the unenhanced one that Dan sent over to us, there's obviously lots of images of stars, and they seem to be bigger but blurrier than they are in the two enhanced ones. So, that's a sharpening, but also in some ways it almost seems like the images got smaller, but I guess that's the blurring of the light, is it, Dan, when it's being corrected? So you're not seeing so much of the blur, you're just seeing the actual source of, well, it's not source of light, obviously the source of light is the sun, but you know what I mean? The reflection on the star is more precise.
Yep. Nope, you got it exactly right. So, so part of that deconvolution process is the apparent size of the star gets smaller in our images, and it puts it more in the proper context of, as you're viewing that from here on Earth, what it should look like from a size and scale perspective versus how it's collected from the camera. So totally. I mean, this is one of those things that, when it hit the astro community, there was admittedly a little bit of controversy about the whole thing because people just didn't understand what was going on. And there was some worry that it was introducing new data instead of just changing our data mathematically to correct it. But I mean, just a radical transformation for us. Now, like the average viewer may look at that and they're like, oh yeah, I see a little bit of a difference. But for us in the astro community, this is huge, right? Because finally you can see structures that would have seemed to be out of focus. And this is like, if you've seen any of the news around James Webb, like folks are freaking out because, now we can properly observe the shape of some galaxies. We can properly observe things that are kind of the interplay between different galaxies. And we're learning things in the scientific community. We can kind of take those same learnings and observe new things about our own images, which is just exciting from a community standpoint.
Well, so I'll take the controversial tack here. I mean, so this is trained on images from the James Webb Telescope, and it's taking a look at what you put together. And now it's sort of saying, oh, well, yeah, on the James Webb, these stars should be right about here, and these stars should be right about here, and this should look about like this. So I'm going to make your image look more like what it ought to look like, or what the James Webb Telescope thinks it ought to look like. I mean, that's kind of, you get to the question, well, why not just use the James Webb images? Because it's kind of getting into that level of, well, is it live or is it Memorex to do a real throwback there? I mean, it's that question of, okay, what is that level that is reproduction? What's enhancement? It seems like we're starting to get into some kind of gray territory there.
Yeah, I mean, I think it's a worthwhile question. And I think, what's interesting about the question of why not just use James Webb. So let's see, I guess from now it was 2 weeks ago, there was a new discovery. It's a new structure, a new nebula that was discovered just next to the Andromeda galaxy. We've been looking at Andromeda for hundreds of years, or for over 100 years, let me say it that way. And no one's ever noticed this structure sitting over there next to it. The point of this is like, we can only point James Webb at one thing at a time. We can only point Hubble at one thing at a time. But you've got all these folks that are just imaging out in the astro community that can look at all sorts of objects, right? And so it's important to the scientific community because people can make discoveries just like they did just last week. And it's incredible to me that people have been looking at this object for so long and no one's ever noticed that structure sitting over to the left of it, or the left of it as we see it here in North America. But so that to me is interesting. The correction part of it, though, it's a worthwhile discussion. And the software developers, went out of their way to explain that it's not introducing any new data. It's merely correcting the data that you have gathered. This is all very mathematical. And not interpretive. So like you were describing a process a minute ago, whereas we use Photoshop to do things, you as the artist get to select what happens and what doesn't happen, right? From a astro development process, it is applying the model across the entire image with no bias, but meaning it's not trying to create an artistic thing, it's trying to create a mathematically correct thing.
Interesting. Well, of course, because amateur astronomers discover all sorts of objects, comets, new stars, all sorts of odds and ends of things.
That's
so
right.
It is such a lively aspect of that. It's an interesting idea to be able to get to this area where we can now enhance that. Mm-hmm. But I guess, Nick, I'm curious. I mean, this is not generative AI, but this is fairly sophisticated in terms of what it's able to do and how it's able to address the image handling pieces in a way at which it would be, if not impossible, certainly impractical for human tactics to be able to address.
Yeah, it would seem so. And it fits into one of these kind of areas I've been looking at for years, into the ways that you're trying to frame the AI opportunity and how it enables us to do things we didn't do before. And I used to have this slide, which I need to resurrect, where it had three comments across it. On the right-hand side, we had automating the complex, which are, self-driving cars. On the left-hand side, we had automating the mundane, which was kind of robotic process automation. And in the middle, the biggest opportunity of everything is augmenting humans to do everything else. And this is, exactly this kind of stuff. It's not introducing necessarily new data. It's making things better. It's enabling humans to do things, better with tools that they couldn't do before. And, as usual with anything that happens like this, and maybe not so much into the astrophotography stuff that Dan's talking about, but in kind of people's jobs, everybody starts going, oh my God, this is going to put X people out of work as a result. And I'd never really believed that. It's basically enabling people to do tasks either they couldn't do at all before or do them better. And, I've seen some people saying, it won't replace you, but it will replace you with somebody who uses generative AI or something like that. But as I said earlier, I think this will become a kind of substrate in all platforms, I think, and we'll all be using it, no matter whether we're in, marketing roles, we're in HR, we're in legal roles, compliance, or it's our own hobbies outside of work. I think we're at something of an inflection point here.
Well, because we've used tools, like I think most folks have got some experience of grammar correction, using editors. Those are things that we could move from, hey, this particular sentence isn't grammatically correct, to being able to now say, write me a paragraph about this particular topic and be able to take it from there. That gets us into some very different environments in terms of capabilities.
It does, but think back to Microsoft Clippy. It looks like you're writing a letter, Nick. Can I help you with that? And Clippy did try and help you with that and utterly failed, I guess. So it's something we've...
I thought some of those Clippy composed letters were wonderfully sweet.
So I think it's a continuation of that. It's just got a lot better. And I think, we've been, as I said, we've been laying down the infrastructure layers for years for this, whether it be, as we've gone through all these kind of things we know about, the large data sets for training, the cloud computing infrastructure, and all that stuff. And it's been preparing the ground for something like this, where we're all now kind of, whether it be as consumers, as people at work, as academics, students, whatever it might be, are now confronted with something that can enhance our ability to communicate. And overall, I believe that's a positive thing. It's obviously going to have, there's going to be guardrails against it. You're obviously seeing things like, public school systems in the US deciding to ban it from their own computers, which is, not particularly... it's a bit of a blunt instrument, because obviously other people have other machines that have chips inside them that they can use to write on. And we're obviously seeing discussions about whether this changes the nature of education, which is based on essay writing, and would it force everybody to go back to exams in person and things like that. I don't think it will lurch that violently in most places, but it's incredibly exciting. I think and some of the companies that I speak to, whether they be the underlying platform companies who've invested hundreds of millions of dollars and euros and pounds in this, or it be the companies that sit on top of them, in some ways, especially the companies that sit on top of them, are growing incredibly quickly in a very, very short space of time. There is a huge pent-up demand, it appeared to be, from people in various roles to enable them to communicate better. And what it leads to is, if you can write, so everybody above the age of, whatever it might be, 3, 4, or 5 years old, if you can write, with these things, you can write better, you can write more, you can write in different styles, you can write software code, you can produce paintings, you can produce videos. These are obviously all from text prompts. And then we have the other things similar to what Dan's talking about, which are enhancing images. It's all part of the same kind of thing, enhancing videos. That's a pretty fundamental shift, I think.
Well, I guess fundamental in terms of capability, but if I think about what that continuum is, I mean, if we take a look at what the internet did in creative process, and think, we were talking about the educational impacts, the ability to find whatever it is that you're looking for on the web, and copy and paste is something that revolutionized the creative process, for better and worse, across a whole range of different industries. We got into that whole question of plagiarism and rights to images, all of those concerns, just simply because now we had access to all of this. Generative AI takes it to that next level and is actually synthesizing something new. And we get into that question of, well, who created it, who owns it, and is it a work that really was created, and is there value in that creative process if in fact we can automate some of that?
Yeah, for sure. There's going to be struggles over intellectual property, and also when you chuck into things like decentralization and blockchain into that as well, that's a whole different ballgame. But I was talking to one of our colleagues here, Alex Johnson, about that the other day, and mixing decentralization and blockchain with generative AI, and you end up in all sorts of interesting areas of, well, at the moment, of confusion. But I'm sure I'm sure there will be, definitely.
Well, so what I've done for this episode is that I used a tool called Descript. There are a few of these tools out there that have a voice synthesis capability. Basically, I spent about 45 minutes reading a script that it then used as a training process to build a model of my voice. It can use that model to create audio from text that sounds like me. In fact, this whole section since I started speaking after Nick's last answer was typed into this program and auto-generated using the model that I trained. We inserted this audio in post. I thought it would be interesting to have this AI version of Eric read some responses I received from ChatGPT based on 2 prompts that I entered. The first prompt was, "What's difficult about creating a podcast on emerging tech?" ChatGPT replied with, quote, "Some difficulties of doing a podcast on emerging technology may include staying up to date on the latest developments and advancements in the field, finding knowledgeable and engaging guests to interview, and ensuring that the content is accessible and interesting to a broad audience. Additionally, emerging technology can be complex and rapidly changing, which can make it challenging to create compelling and informative content. Podcasting is a crowded space, and you would have to work to make your podcast stand out and be found by your target audience," end quote. The other prompt I gave ChatGPT was, "What's important about emerging technology?" ChatGPT responded with, quote, "Emerging technologies have the potential to bring about significant advancements and improvements in various industries and aspects of life. Some of the best things about emerging technologies include increased efficiency, productivity, improved communication and connectivity, greater convenience and accessibility, advancements in healthcare, and environmental benefits. It's important to note that any technology can have both benefits and drawbacks, and it's important to consider the overall impact of the technology on society," end quote. Okay, so we'll switch back to the real Eric at the end of my section here. I guess we'll leave it up to our listeners to decide what they think about the AI version of me and whether or not we should start heading in that direction for podcast creation. So yeah, very, very interesting directions in terms of where we could potentially go.
I wouldn't want to lose your dulcet tones, though, Eric, because the world would be a poorer place without that.
Agreed.
Well, I guess it will be interesting to see the level of dulcet. But again, we'll leave it up to our listeners to decide. Well, thanks to both of you. I appreciate all these perspectives. We're definitely in a very interesting new environment in terms of what these technologies can do and how we can go put them to work. But it's been great having you back on the podcast.
It's been great being here. Thanks, Eric. And thanks, Dan.
Yeah, thanks as always, Eric. Appreciate it.
And that is it for this episode of Next in Tech. Thanks to our audience for staying with us. And thanks to our production team, including Carolyn Wright, Ethan Zimmon, and Syed Waji Abbas on the marketing and events teams, and our studio lead, Kyle Canilosi. I hope you'll join us for our next episode, where we're going to be talking about new sources of data, the data center knowledge base, and a lot of the perspectives about how that can be put to work in these much larger contexts. Actually, a bit of a step beyond the kinds of things we've been talking about today, new data sources that we can use to synthesize new and better perspectives on our environment. I hope you'll join us then, because there is always something next in tech.